Alright, problem number 5. A 6-gallon block initially at rest is pushed against the wall by a 100 Newton force as shown. The coefficient of kinetic friction is 0.3 while coefficient of static is 0.5. Draw the free body diagram. Alright, so let me give myself a little bit more room. So here is the block. Right, we have the force applied. Right, and that's still at 60 degrees. So the force applied right there. Next we have gravity, mg. We're also touching, so we have a normal force. And then we must have friction. Well, we may not need friction. Okay, so we have to find out if we even need friction or not. Because if I was looking at this, now don't draw it for your free body diagram, but you can do it yourself. I have force applied in the x and force applied in the y. Now, if force applied in the y is as big as gravity, then I won't need any friction because it's already balanced. Okay? You can practice the trig and you can get force applied in the y equals 87 and force applied in the x equals 50. Okay? So if you do those, then you can see if you need friction or not. So if we looked at, this is going to be in the y direction. Okay? Force applied in the y, force applied in the y minus gravity equals ma. So this we said was 87 minus the force of gravity. For this one, what's the mass? So that's 60 equals, what do I have? Well, that is not 0, so then I have to put friction in. Right? So if I look at this, I have 27 newtons upward. So I have to then have friction. All right, this is going to be force of friction also going upward. Okay? Now we have to decide, is it kinetic or is it static friction? Well, let's go up here and see, because remember, we just solved the kinetic and then see if we're using that or switch, or sorry, we stalled with static and then we see if we have to switch over to kinetic. So I know force apply, no, don't want that. I'm looking for force of friction static max. I need to see if I have enough. So that equals mu Fn. Right. The coefficient, it gave it to me. That coefficient is 0.5 times Fn. Well, and this is a weird one. Where is Fn? Well, Fn is in the x direction. Right? Is it accelerating the x? No. So that means force normal here has to be equal to max. So that means max, you can see I solved fax here, is the same as force normal, and that is 50 newtons. So now force of friction static max will give me 25 newtons. Okay. So back to our setup, we said we had 87 newtons up, 60 newtons going down. So overall, I think we said we have 27 newtons upward. Static friction can only handle 25 newtons going down. Right? That's not enough. So now again, I have to switch and go to kinetic. Right? So let's start this mess all over again. Right? So now I can do my free body diagram on the entire thing. So now I can say, well, here I'm going to have in the y direction force of friction plus Fay, and then minus mg equals ma. So force of friction, we went farther on this and we said this is mu Fn, mu kinetic, plus Fay minus mg equals ma. So now we can plug numbers in. So here we can do 0.3 times Fn, which we said was 50, times F plus Fay, which we said was 87. Let me check something real fast. Alright, so what I started getting confused with was my force of friction seemed a little off. because if I have this problem, if I have 87 minus 60, that's going to be 27 newtons going up. But that's not going to work. Right? If friction's going up, it's going to be even larger, so that can't make it go faster. So I should have changed, and friction should have been going down. So friction should be going down, and you get a negative answer here. This should be negative. Because friction has to try and balance things out. It's going to slow them down. So this shows it would be going up without friction, so friction has to be opposite of that. So this was a negative, plus 87 minus 60 equals MA. Oh, and mass is 6 here. So do that algebra. Let's see, so negative 0.3 times 50 plus 87 minus 60. I got 12. 12 divided by 6 equals 2 meters per second squared. On the key it's a little off because I believe, well, I know they are now, on the key they're using 9.8. So that's good there. Normal force we've already done, and acceleration we've already done, all in that problem. Alright, now here we can problem number 5. So it asks for the coefficient of friction. Well, I don't know how much friction's there, so I have to start this kind of over again and do a free body diagram. So let's look at this one and let's see what forces are acting on this person. Well, we know we have gravity, that's straight down. So that's mg. We know we have the normal force, Fn. Let's double check something real fast. It says determine the coefficient of friction. Okay, that's for the coefficient of friction. We must have friction then. So friction would be going up. That would be the only thing you would put on the free body diagram if it asked you in the test on a response. Then if you're trying to solve it for yourself, though, you want to put in components. We've joked about this a lot. What sends you to the bottom of the ramp? That is mg sine theta, and here you have mg cosine theta. So it's asking for the coefficient of friction, so that's in the x direction. So let's start with my net force in the x. So net force in the x would be mg sine theta minus force of friction equals, now did this one say constant speed or constant velocity? Let's test it out. There we go, constant speed. So if you're going at a constant speed, your acceleration is 0. So then this side equals 0. Right? So now I can keep going because I need the coefficient of friction. So this would then become mg sine theta equals force of friction, which is mu Fn. Now do not say Fn equals mg. That is, for every specific problem that will change. Right? So if we do it, we can see Fn does not equal mg because they're not lined up. So I know the acceleration in the y direction, so up or down, is 0 because it's not going down or up. So if I did my Fnet statement in the y, I would say Fn minus mg cosine theta equals 0 as well there. So then I know I could add this to the other side, and so Fn equals mg cosine theta. So this becomes mg sine theta equals mu mg cosine theta. Now I got to solve for mu. So I divide by mg cosine theta to both sides. Right? Mg cosine theta to both sides. So this all cancels with that. This m cancels that. This g cancels that. And we've seen what a sine gerene over a cosine gerene is. That is a tan. Now, instead of gerene, we just have theta. So we keep this as theta equals mu. All right, so this problem, it's very similar, except it says it doesn't move at a constant speed. Calculate the acceleration. Well, we saw before in the x direction that we have, let's see, that we have mg sine theta minus the force of friction, which was mu mg cosine theta, and that equals m times a. All of these masses are identical, so the masses would all cancel out. And so I believe that's my equation for the acceleration. Right? Everything else here is a constant. You know the angle here. We know g. We know g. We know we could do theta, like I said, so we could solve for a there, if only I knew the numbers.